Alrighty, here we go. So today's lesson is on solving systems using elimination. Solving systems using elimination. So today we're going to start off basic, meaning we're not going to jump into the really challenging stuff. We're just going to use elimination for basic. So our I can statement, I can solve systems of linear equations using elimination when opposite coefficients are present. I can solve systems of linear equations using elimination when opposite coefficients are present. So I made sure to use the word coefficient yesterday. So someone tell me what the word coefficient means. We used it yesterday when we were talking about kind of doing our 5.3 wrap up or recap. And I made sure to talk about the coefficients because when we're using substitution, we're looking for a coefficient of 1. What does that word coefficient mean? Because if we don't know what it means, then we're not going to be able to solve. What is a coefficient?
It's the number before a variable.
It's the number attached to the variable. A coefficient is the number attached to the variable. So I'm going to just put a little note here so we know. It's the number attached to the variable. You need to get up and go see if you can find a writing utensil. Look in one of the baskets or the buckets. Okay. So I can solve systems of linear equations using elimination when opposite coefficients are present. And coefficient is the number that's attached to the variable. You got something? Okay. So the steps for solving using elimination. So it says when opposite coefficients are present. So that means that if we want opposite coefficients, that means I'm looking for a 3x in one equation and a negative 3x in the other equation, or a negative 2y in one equation and a positive 2y. So the coefficients, same number, but they're opposite. All right. So the steps for using elimination. Number 1, we want to make sure that those equations are written in standard form. Standard form. AX, Isaac, pick your head up, please, and thank you. AX plus BY equals C. And then you want to make sure that you line up your X's and your Y's. You're going to kind of stack the equations right on top of each other. And then look for opposite coefficients in the X term or the Y term. So you're going to stack your equations on top of each other. Make sure that your X's are lined up, your Y's are lined up, and then your constants will be lined up. And you want to look for opposite coefficients in the X's or the Y's. You don't need opposite coefficients for both, just one. So we're going to eliminate them. What do you think we should do if one of the equations doesn't have opposite coefficients? They just have the same. Like what if it's 3x, 3x? Those aren't opposites.
Maybe combine them.
I need them to be opposites so I can eliminate one of them. How could I make one of those negative? If I have two positive x coefficients, how could I make one of them negative? Think about what you do to an equation. If you have negative x equals 2, how do you find out what positive x is? You multiply everything by a negative 1. And I think that's what the next line says. So we're looking for opposite coefficients on the x term. looking for opposite coefficients, it says note, if you have the same coefficient, but they are not opposites, you can multiply one of the equations by -1. You can multiply one of the equations by -1. Remember that when you do that, you multiply every term in the equation, not just the one that you want to be opposite. You have to multiply every term in the equation by -1. So when I look at this system right here, do you see opposite coefficients? Do you see opposite coefficients? Well, I do. I have a -3y and a +3y. Do you see that? Do you see what I'm talking about? Okay. So when you're using elimination, the next step is that you add those equations together, and you essentially are going to eliminate one of the variables. So this is what it looks like. I'm going to put a bar under here. We are adding these two equations together. So I want you to make sure you write that down so you know what the process is. I'm not just doing this because I like it. So 2x plus 4x is 6x. That's where this comes from. 2x plus 4x is 6x. A -3y and a +3y cancel out. 12 plus 6 is 18. And then we do what? How did we get from 6x equals 18 to x equals 3?
We divided both sides by 6.
Yeah, we divide both sides by 6. And we find out that x equals 3. Okay. Divide both sides by 6 to discover that x equals 3. And then what do? It says, well, you substitute the value of the variable back that you solve for in step 4 back into the original equation and solve for the other variable. So what equation do you want to use? Do you want to use the 2x minus 3y equals 12 equation, or do you want to use the 4x plus 3y equals 6? Makes me no difference. Pick one.
How about the 4x plus 3y equals 6?
Okay, so we're going to use this equation, and we're going to sub in x equals 3. That's what it says to do. So we have to figure out what y is, right? So this equation is 4x plus 3y equals 6. But we just solved for x. We know that x equals 3. So I really have 4 times 3 plus 3y. Sorry. Equals 6. What is 4 times 3? 12 plus 3y equals 6. What do you want to do next? Yeah, we're going to subtract 12 from both sides. Slide all this up if I can. So when I subtract 12 from both sides, I get 3y equals -6. Divide both sides by 3. Y equals -2. Am I all finished?
Oh, no, you have to write the ordered pairs.
Yeah, write this as an ordered pair. Remember that your solution is an ordered pair. So I'm guessing it's the ordered pair -2, 3. No, why not? X goes first. X goes first. So it's the ordered pair 3, -2. Good job. 3, -2. X comes first. Step 6 says write your answer as an ordered pair. We did. 3, -2. How do we feel about that? Good. Does anyone need more time with that? Lysandra, are you good? Okay. Next page. So remember, we're looking for opposite coefficients. Do I have a pair of opposite coefficients?
y and a negative 5y.
Yeah, what's going to happen when we add these two equations together?
They're going to cancel
They're
out.
going to cancel out. 2x plus 6x is 8x. 17 minus 9 is 8. Next step.
Divide both sides by 8.
Yeah, divide both sides by 8. X equals 1. Okay, now what do I do with that? What do I do with the x equals 1? Yeah, which equation do you want to work with? The first one? Okay, so Ariana says we're working with the first one. 2x plus 5y equals 17. And we are subbing in x equals 1. That's what we're going to do. So I'm going to rewrite this as 2 times 1 plus 5y equals 17. What should I do next? Perfect. Subtract 2 from both sides. So 5y. Perfect. So my solution is what? You're doing great. Perfect. What do you think? You like it? Aiden, did you shake your head no? You don't like it? You like it? Yeah, I like this method so much. Okay. All right. Are we ready to go to the next one? Raise your hand if you still need more time with this. I feel like I might have some sleepy peepees. I'm going to walk over here. Okay, so the next one. Example number 2. Do we have opposite coefficients? Yeah, which ones? 4x and the negative 4x. Do you guys notice how I always circle my opposite coefficients? When I do stuff like that, it's not because I want to, it's because I think it's a good math practice, right? So you know what your opposite coefficients are. So remember, we're going to add these two equations together. That's the rule. We're going to add them together. So what's going to happen to 4x and negative 4x? Cancel out. Perfect. What is negative 2y plus 4y? It's 2y. And what is negative 1 plus negative 2? Negative 3. Oops, that's a horrible looking 3. Negative 3. So next step, Isaac. Divide both sides by 2. So y equals negative 3 halves. I'm going to leave it as a fraction. I know that negative 3 halves is the same thing as negative 1.5, but I'm going to leave it as a fraction. So, what are we going to do with that? Next step. Which equation do you want to use? The first one. So 4x minus 2y equals negative 1. And we are going to sub in y equals negative 3 halves. So let's see. I have 4x minus 2 times negative 3 halves, and that equals negative 1. Remember that the whole number 2 is the same thing as 2 over 1. Okay? What happens to the denominators? The denominator, well, not necessarily. Yeah, it stays the same. We're multiplying straight across. So do you guys remember that we can actually cross reduce? Do you remember that? I mean, that's like why we multiply by the reciprocal, right? So we can get rid of the denominator, cross reduce. So the denominator and the numerator of each fraction is opposite, or like they're the same. We're able to cross those out using cross multiply or cross reduce. So you still have a negative times a negative 3 equals what? So I have 4x plus 3 equals negative 1. What would you like to do next? Yeah, subtract 3 from both sides. So 4x equals negative 4. Last step, Brianna. Divide both sides by 4. Good job. X equals negative 1. X equals negative 1. Tyler, very last step. What do I do? What is my ordered pair? X, comma, Y. Tell me again. No, you're fine. Perfect. Negative 1, comma, negative 3 over 2, or negative 3 halves. It's excellent. Thoughts?
I like this better than.
You like this better than substitution? Yeah. I think it's fewer steps. And plus, here's why I like this so much. Do you guys remember when you first learned how to add, even if it was just like a one-digit number with a one-digit number? You know how you stacked them on top of each other? And then you started doing a two-digit number plus a one-digit, or a two-digit plus a two-digit, and you stacked them on top of each other? This makes my math brain happy, because this is how we learned how to add, digits together. And so I feel like if you have numbers kind of lined up and you're adding them, it makes more sense. It's just like adding a three-digit number plus a three-digit number. Are we good with that one? Okay. Let's go over to example number 3. Okay, so we're looking for opposite coefficients. Do we have that? We don't have opposite coefficients. These coefficients are the same. What do we do if the coefficients are the same and not opposites? Multiply by negative 1, and we have to just pick one equation and multiply by negative 1. So I typically take the bottom equation and multiply it by negative 1. So nothing is happening to the top equation. Do you see that? So I just rewrite it. 6x plus 5y equals 4. The bottom equation, every single term is getting multiplied by negative 1. Every single term. So negative 1 times 6x is negative 6x. A negative 1 times a negative 7y is a positive 7y. A negative 1 times a negative 20 is a positive 20. So when I add these two equations together, here are my opposite coefficients that will cancel out. So now I have opposite coefficients. Aiden, are you with me? Pick your head up off your hand, please, and thank you. So what is 5y plus 7y? 12y. And 4 plus 20 is? Just 24, yes ma'am. And then next step, Tim, what are we going to do next? Divide both sides by 12. So y equals 2. Lysandro, what are we going to do next? What are we going to do with that y equals 2?
We're going to take another equation, those two,
Which equation do you want to use? The top one or the bottom one?
top them.
Top one. So we're going to take this equation, 6x plus 5y equals 4, and we are going to sub in y equals 2. That's what we're doing. So let's see, I still have 6x plus 5 times, what is y? 2, equals 4. Okay. 8 and S, what do you want to do next?
Multiply the 5.
What is 5 times 2? So 6x plus 10 equals 4. Aiden A, pick your head up for me. Thank you. So what's the next step, Isaac? Yeah, subtract 10 from both sides. Good job. 6x equals -6. Victoria, what do you want to do next? Divide both sides by 6. X equals, I heard someone say it, x equals -1. All right. Kylie, final answer. Remember, it's an x comma y ordered pair. X comma y ordered pair. What is x? What is x? -1. So you say -1, comma 2. Okay, make sure you put your x first. Good job. Okay, how do we feel about that? We feel like we are embracing elimination. So we know that if we have the same coefficient and they're not opposites, what are we going to do? Yeah, multiply by -1. One equation. Just pick one equation and multiply every stinking term in that equation. You can't just multiply the coefficient that you're trying to change. Everything has to get multiplied by -1, okay? All right, you guys know that we'd have to do a word problem, right? Because applications are really important. So Alyssa is a costume designer for the local children's theater. Yesterday, she sewed 5 female costumes and 2 male costumes, which used 55 yards of fabric. Today, she sewed 1 female costume and 2 male costumes, which used a total of 19 yards. How many yards of fabric does each costume require? So we first of all have to define our variables. So here's what I'm going to do. I know that I sewed 5 female costumes and 2 male costumes for a total of 55 yards. Total of means equals, right? I also know that I sewed 1 female costume and 2 male costumes for a total of 19. The question is always the variable. The question that's being asked is always our variable. And the question is, how many yards does each type of costume have? So what 2 types of costumes are we using? Well, we have female costumes and we have male costumes, right? So if we let the first variable be the number of female costumes, do you want to use X or do you want to use F? X, yeah, I agree. I always try to use X and Y, even if, like, sometimes you guys will read story problems and they use the letter of, like, whatever, like M for miles or whatever. That really throws me off. I change the variables anyway. So then the next variable, Y, is going to be the number of male costumes. Because again, remember that the variables are always the question. So how many female costumes did she make on the first day, yesterday? She made how many female costumes? 5. So that's going to be 5x. Plus, how many male costumes did she make? 2 times y equals 55. And this is actually not going to be the number, it's going to be the number of yards. Number of yards. I'm going to throw that in there. Okay, so that's how we're going to set up our first equation, which is in standard form. Who feels like they can set up the second equation? Go ahead, Tim.
2x.
How many female costumes did she sew the second day? That's all right. So 1x.
Plus 2y equals 19.
Okay. So those are our equations. This is our system, right? This is our system. Do we have opposite coefficients? We don't. Which one do you want to multiply by -1? Yeah, I always multiply the bottom one, so that way I'm, like in my brain, I'm subtracting. So we're going to take this top equation and not change it at all. I'm just going to rewrite it. 5x plus 2y equals 55. The bottom equation, we are multiplying every single term by -1. So that means I have -1 times 1x, which gives me -1x. I have -1 times 2y, which gives me -2y. And I have -1 times 19, which gives me -19. So now we have what we're looking for, opposite coefficients. What are our opposite coefficients, Tyler? So I'm going to put a big old circle around them and cross them off, because we know that they're going to cancel out, right? We're going to add everything else together. So, Avery, what is 5x minus 1x? It's 4x. So 4x equals 55 minus 19 is, say it again, 36. Okay. Aiden A, what would you do next? Divide both sides by 4. We find out that x equals 9. Okay, what are we going to do next? Substitute 9 into what equation? Tyler, you're doing great. What equation? The first one. So the first equation, 5x plus 2y equals 55. And Tyler says, hey, we're replacing the x with a 9. 5 times 9 plus 2y equals 55. What is 5 times 9? 45. Plus 2y equals 55. Subtract 45 from both sides. I love that. $10. Good job. 2y equals 10. You guys are doing great. Keep going.
Divide both sides by 2.
Absolutely.
And y equals 5.
So what is my solution? 9, 5. This is a word problem. So what does the 9, 5 represent? So 9 yards for each female costume. And 5 yards for each male costume. Thoughts? Like it, hate it? Like it? Okay, hang on a second. So here is what we're going to do. I'm going to freeze this screen really fast so I can pause our video. So